Good morning, everybody. I hope you read me well, and it's my pleasure to welcome you to this co-creation session on top-down topics for EIC Pathfinder. As you know, EIC Pathfinder will have both a bottom-up component and a top-down component. And I would like to present you a few of the topics that we are exploring and ask your opinion about it, but also the opinion of our two distinguished speakers. So have a look at the structure of the session. I will quickly present these 9 topics, and then I will invite our esteemed speakers to intervene as well. And we'll have time for some Q&A and hopefully some intervention from you, from the audience. And at the end, very important, we'll present some live polls so that we can gather your feedback on that. So we have with us today Mr. Radu Georgiou, who is a practitioner, and he's a founding member of the Institutul de Prospective, sort of Prospective Foresight Institute, and he's a foresight researcher and practitioner. And as a second discussant, a second speaker, we have Mr. Manuel Noya, who is a co-founder of Linkovate, who is a competitive and intelligence startup. He will present himself a bit later, both of them. So let me start, go right into the session in the interest of time. So we'd like to present you this and inform a bit about how did we arrive at these topics and to gather your views. We have started very broad, as we usually do. We did some horizon scanning. We have a CSA to help us, prefet, to help us in here. We had a few stakeholders consultation and workshops. Our project officer contributed, our program managers, and then we gathered, I think, around 35 topics. And then we had some criteria. You see them on the screen, and then step by step we reduced them to a list of around 9 topics. And these topics are basically we put them in 3 categories. First of all, digital, health and biotech, and energy and environment. So let me briefly introduce say a few words about each and every one of them. So in the digital, we have self-developing and aware artificial system. Here, well, the challenge here is to move from us as a individual centric to a more generalized awareness that could be applicable to, let's say, any sufficiently complex system, of course, non-human and artificial ones included, and to demonstrate here what are the technology needs, what are the implications for us as a society, but also to explore the limits, the technical issues, the ethical issues. Sorry. The second topic that we look into and would like to present today are computing technology for digitization of chemistry and drug production. This starts from the assumption that the chemistry has been relatively slow to digitize compared with other sectors like telecom or even finance. And here we would like to investigate some radical new machines like microreactors to make specific drugs or any other chemical substance that could be, for example, printed or assembled on the spot. Together with some electronics, other stimulus, and do so in a safe way. The third topic, which is coupling the real and the virtual in self-optimizing spaces and artifacts. Let me start by saying that this is definitely more than digital twins. Is basically closing the other loop from the cyber to the physical. So here the idea is to have a sort of self-assuring cyber and physical system, and these physical artifacts are working in conjunction with their virtual or let's say, a cyber counterpart. And this hybrid construction can adapt and transform so that it keeps itself in a state that is in a near optimal or a safe state. If we move now to the second group, biotech, health and biotech, we have here the tools to read, write from in the brain. Here, basically, this topic would have, on one hand, we try to explore new physical principles that would be the basics for the future technologies, sensing or stimulation brain technology. And then on the other hand, some novel devices, implantables, but not only, that have certain unique features that, for example, can target an untreated disorder. They offer unprecedented characteristics, size, invasiveness, and so on. I would say, quite an actual topic, if you agree. And the second in this category would be emerging technology for cell and gene. Again, cell and gene therapy, it's a very wide topic, one that I think there is almost no week where there is no news on that. So the challenge here would be, well, for example, just as an example, to extend the application of the cell-based therapies from blood to solid cancers, to have no or in the worst case limited risk adverse, and to look at the new genome editing technology, and of course to combine the cell and gene therapy. The last but not least, we have mechanistic discovery as single cell resolution. Here again, a topic with a high potential on each and every one of us. The idea would be to develop targeted single cell tools to more, for example, to specifically check biomarkers or mutational signature, and or technology to improve the cell capture rates. For the moment, this is very difficult and expensive. So the idea would be to bring here a step change. Let me go to the last topic here, which would be the energy and environmental. Here, the first topic that we are looking into, to look for breakthrough thermal energy recovery, storage, and conversion. In a true FET or Pathfinder spirit, we would like to start at the lower TRL from 1 to 3, to look for, let's say, multidisciplinary exploration for thermal energy recovery, storage, and conversion. Here, of course, the challenge is, for example, to go at a much higher temperature, 2000 Celsius, to make sure that there is stability in the charge and discharge cycle and long-term operations. If we move to the disruptive technology for sustainable and toxic-free farming, again, a technology that impacts each and every one. The challenge here will be to look for new compounds that are sustainable, whether fertilizers or herbicides that are, but also for the technology that are sensing the plant's needs, biorobotics, large-scale system of supervision that would, let's say, detect if there is any stress in the farm. Last but not least, engineering living materials. Here, the idea is to establish a sort of a platform, if you want, that could produce this on demand and customize living materials. Of course, what we want is to have predictable functionalities and performance that for these materials, whether we are talking about small scale materials or bigger scale materials. That would close for me the the brief presentation, and I'm specifically brief because I would like to give the opportunity to our speakers to present what is their opinion. So I would like first to invite Mr. Radu Gheorghiu, and let me put up the screen his slides. So Radu, thank you very much for being today with us, and I give you the floor.
Thank you very much for inviting me. This is a very special place to be, I think, because Pathfinder and EIC are dealing with the frontier topics, the ones that are very much into the future. Also, some of them building on already existing trends, and other pushing the new into new paradigms. It's indeed a very special place to be, and thank you again for inviting me. I will move to the second slide and tell you very briefly my perspective. I am a co-founder and the president of Prospectiva, which is an NGO with a logo, a bird, but inside of it, it is a machine. It's a combination of machine learning and human evaluators. We are crunching a lot of information from technology news all around the world. We have more than 3 million news, but also markets predictions, scientific articles, and so on. And from this machine, we are trying to identify weak signals, trends, and scenarios. What I'm trying today to do is to do a little reverse engineering. So you have the topics. I have also been involved in contributing to some of them, but in much larger groups. Now I'm trying to see if from our repository we have trends supporting this some of these topics that you have described. And with no particular order, I will start with these tools for read and write activity in brain tissue, because it is a very dynamic field right now. We find a lot of innovation, not only in publication or proof of concept, but many already in the market or available. But still, we cannot talk about a mature field. We are talking about a process of very rapid increase. We see this increase or this innovation in brain functional mapping, for instance, understanding electrical activity, not only in areas of the brain, but as a total network, understanding memory function, and so on. We see a lot of innovation in brain-to-machine interface, both on brain sensing, where you already have wearables for device control, like in gaming, for instance, available on the market. You have proof of concept for decoding spoken dialogue from brains, directly from brain signals, which may be important for people with disabilities. And a lot is happening also in brain stimulation, both in transcranial stimulation, which can be magnetical, optical, ultrasound, and so on, with mainly with application in health. But you already have, you also have like a competing, let's say, technology, the implants, which are becoming smaller and smaller, like dust-sized, better connected by wireless connection. And you have recently the famous already tested on animals implants, tested on pigs recently. There are also efforts in the idea of brain-to-brain interface, which means that basically information from one brain is transformed into a machine and then by ways of stimulation are transferred in another brain. Here there are, let's say, more of toy examples or proof of concepts, but the concept, but it is a very promising and probably a radical innovation for the future. Right now we have exercises like people playing together a Tetris game, but the sky is the limit when thinking the application, what could collaborative minds could do together in different tasks. It could even open for kind of collective intelligence, if you want. The field is also intensely discussed in terms of ethical issues, especially in this idea of brain-to-machine interface for not so much for the health issues, as indeed the fact is that the market prospect is more in other industries like gaming, for instance, or even social networks. So ethical issues are high on the agenda, and in terms of implants, the issue of biocompatibility are also discussed. I will move now to another topic, which is the coupling of real and virtual in self-optimizing spaces and artifacts. This is a very interesting topic because it is building on a kind of mega trend, this convergence of real and virtual, where we see, for instance, the digital twin, meaning like replicas of physical objects, like or which can be an entire factory or a smaller product. Initially, these digital twin were made for before really making the product, but now they are used in parallel with the product for running different simulations. So we see a clear convergence here of real and virtual. And then we have optimizing systems using artificial intelligence, using IoT for getting the signal from the real systems and understanding its real dynamics. Of course, this process can be more or less sophisticated because in any way, even a simple feedback loop from the system is an optimization. So the very definition of optimization can be discussed, enlarged. But we see integrated system, first of all, in communication networks, probably the first ones that have embedded optimization systems, but also in other new fields like microreactors or factories, in the case of a photovoltaic factory, for example. I think we have added another kind of technologies or trends that might help this endeavor of coupling the real and virtual in self-optimizing systems, the idea of reconfiguration. Because if we think an optimizing system, we think in terms of information we get from the system, but also in capacity of changing the system to the desired state. And we think that a reconfiguration of the very system, the possibility of the system to reconfigure itself is very important. That's why we might also consider for instance, the shape-shifting materials. They can adapt to improve the quality of the system, but also claytronics, which is reconfigurable nano scale robot. Again, we think that this is this topic, it builds on a mega trend, and then the direction is clear, and there is opportunity for converging of various technologies for achieving these self-optimizing spaces and artifacts. I'll move to another one, which is related to this, which is self-developing and aware artificial systems. It's a topic which I'm particularly fond of. I was part of the fabulous team that proposed it. People with more knowledgeable than me in cognitive science, in materials, and so on. Very interesting. And I think this is kind of peculiar in relation to the other, because you have existing trends like progress, a lot of progress in artificial intelligence, new types of algorithms. You have emotion recognition and sociable robots, which looks like awareness, but of course it is not necessarily awareness, but it starts to look like. You have the social pressure, more of demand yet, for responsible artificial intelligence. So artificial intelligence can embed ethical rules, but also be more transparent in decisions. Again, you have more evolutionary artificial intelligence, which is closer to the real life. You have already robots that can learn their body capabilities by themselves and create a kind of corporal schema into their mind. But I feel that in this particular topic, the aim is higher than the current trends. So it is not only a crazy idea produced by a group of people. It is there, a kind of counter trend, if you want. The idea that we should go beyond the black box model of deep learning, for instance. The idea that we could have robots with internal model of themselves, robots that understand themselves as part of an environment, robots that can have a theory of mind, so they understand can have expectations about the other's behavior in relation to their action. So they have an inherent anticipatory capacity and an explorative what if questions. So that's a kind of counter trend in relation to the deep learning currently in mainstream, a counter trend which in fact revives an older hopes, probably from the early age of artificial intelligence. But this is not all, because in fact this topic calls for the very definition, a broader definition of awareness, definition that there are key VIP scientists proposing, exploring these new definitions. Some are contested. The debate is still high, but it is very important to enter into more systematic and making it a little more mainstream, even at the space of in terms of dialogue. The idea is that, can we talk about awareness of a factory? Can we discuss the level of awareness in a complex system like a transport system, and what is the relation with the structure of the system, with the energy, the information inside such a system? But one question remains somehow. It is, why do we really need them to be aware? It's not enough. For instance, we have smart houses. Do we need an aware house? Why is this important? And of course, if we think in terms of awareness, like human awareness, it probably is. We don't know why we want so aware house, but it is clear that some capabilities are can be very useful for a system. Of course, this is a toy example, but imagine this: you have the house discovered there is no person in the house, and the house discovered by sensor there is a split of water into the kitchen, and now a smart house doesn't do anything, in fact, or if it's already programmed to transmit this information, that will probably do it. But this warehouse, it is able to make an investigation. What's the problem? And maybe which are the solution? So imagine that, joking a little bit, that the house asks the machine, the washing machine, is it you? And the washing machine says, no, my sensors are okay. The input water is 0, so I cannot have output water. Then the house asks the refrigerator, is it you? And the refrigerator says, I don't really know, because the dog ate my door sensor 1 hour ago. The house looks closer into the fridge and sees, indeed, the door is open. And then the fridge says, I need to accomplish my mission. I have a mission, which is to preserve the food by tonight, when there is a party, and I have to preserve the food, and suggest to the house, please cool the house, that basically the food stays the same temperature. But the house says, I cannot, because the dog is in the kitchen, and my mission is to take care of the dog, which means a certain temperature. But then comes with an idea, with a what if. The idea is that I will ring the bell from the door. The dog will run at the door. It always does that. And I will close the door of the kitchen and then cool only the kitchen, not the entire house. Of course, this is a toy example again, which can be some could come with more sophisticated or more valuable examples. What I wanted to prove is that awareness is an important step for having objects or systems that basically negotiate, explore solutions. And that's all about this awareness. My last slide is about quite a different topic, which is the technologies for toxic-free farming, which is building, of course, on the high demand for clean soil, less energy consumption. We know that, for instance, the fertilizers consume 1% of total energy in the world, not including their transport and put in place. It's only the production. So there is a huge pressure into clean and less energy consumption. Here we have already some kind of mature markets, like slow and control release fertilizers and pesticides. This slow and control release component is about 2% of the global market of these products. It is increasing faster than the global market of fertilizers and pesticides, but still is very low. And it's also facing issues of environmental impact, because some of these capsules used for this control release are in themselves damaging the soil. What's happening right now, as we find in our radar, is a lot of progress in plant sensing. So understanding better the real needs of the plants. Maybe we don't need so much fertilizers and pesticides. We need to go into precision farming, which is again high on it's increasing very fast. You have IoT, nanosensor, biodegradable sensors, spectroscopy. So better understanding the plant, better targeting the action. Okay. In what regards the slow and control release fertilizers and pesticides, we have more environmentally friendly solutions, like cellulose nanofibers from bagasse, which is a remaining of the after the extraction of juice from sugarcane. So biomaterials, and we have also quite mature or new solutions for new ways of control, like for instance, light responsive control release. So you activate the pesticide in a certain way by more targeted external control. But this is already, I think, entering in quite a mature phase. What is already in the announce of the topic, and I find like a game changer, is this idea of microbes, of collaboration of the plant with the very microbes. And here we found that there are some early attempts, for instance, of engineering soil microbes for produce ammonia that can support plants to grow larger. This is seen currently mostly as an alternative to current pesticides for lower income countries, but it may indeed prove as a solution for the others. And the more radical solution, which I found very interesting, is the engineered cereals, for instance, to activate root microbiota for nitrogen fixing. So the plant is communicating with this microbiota, with the bacteria, and it demands it to help into nitrogen fixing, so reducing basically the need for fertilizers.
Thank you very much, Radu. Really excellent insights, and personally, I enjoyed the scenario of the house, even if I don't have a dog. So let me ask Manuel to come in. Manuel, I'm just putting your slide. Over to you.
Hello, everyone. My name is Manuel Noya. I'm the co-founder and CEO of Lignovate, and I'm just gonna start with our story. So very briefly, we founded Lignovate in 2013 in Stanford University after applying 3 times to Stanford University Accelerator Program. It's one of the accomplishments that we are most proud of. In 2016, we won the competition from the European Commission, Finodex, on open data for startups with over 100 applicants. And until 2020, we were lucky enough to get selected by Microsoft Ventures program in Berlin and being awarded more than 7 European grants. And actually, the European Commission was absolutely pivotal in us moving back from California to Spain. These are some of our clients today in over 10 countries, and we have users in almost every country on earth. Some of them are researchers, and they use our software for free. And today, I'm just gonna talk to you about the future, and this is how we see the future in Lignovate. This is the website of one of the main banks in the US, Wells Fargo, and these are all the small startups and the small research lines that are trying to disrupt every single service or business line that they have, from peer-to-peer lending to investment to rentals, etc. And this is not only true for fintech, it's also true for agri-tech, biotech, automotive, aerospace, retail, insurance, you name it. And today I want to highlight, not because we are participants in them, but because of their flexibility, 2 initiatives from a public organization, which is the European Commission. So the question is, are corporations, are organizations doing something about this? Yes, they are. They are opening corporate venture capital funds. They are opening accelerators, incubators. They are opening advanced technology offices in Silicon Valley. But we need more than that. And this is where these initiatives come into place. So these are 2 initiatives I want to bring up today. One is Next Generation Internet NGI Pointer, where we are partners. This is an open call where we found and what we call the next generation architects in many topics, so people can propose solutions, innovative solutions on anything from energy efficiency to anonymous and privacy technologies, to network optimization, to new TCP/IP protocols. And the second initiative that I want to bring up is PREFET, as VRL mentioned early on. This was the CSA for the FET program, and here we highlighted 45 pre-validated trends. Pre-validated meaning that we then selected thanks to a series of steps involving experts and involving an open trend, what we call an open trend consultation, and the very first Trendington, which was a small workshop conference that we did to discuss trends for the future, and came up with our 20 final trends, from which this is just an example, self-healing batteries, and you can actually go online and check this interactive map and this interactive periodic table that you just saw. And some of these trends actually inspire some of the topics VRL presented before. And particularly, I want to bring some insights to you on two of them. One is engineering living materials. The other one is computing, which actually was one of the topics that we discussed and came up in PREFET. So engineering living materials, this particular topic we can highlight, and I'm going to just go in less than 30 seconds over it. We can highlight three things, as we always do in PREFET with every emerging trend. We can highlight the goal of this trend, which of course is creating engineering materials composed of living cells that assemble the material and modulate functional performance of this material. We can highlight some phases of research. They are, of course, not the only ones, not even probably the most relevant ones, but some of the ones that we want to highlight because of their pioneering work. And, of course, some institutions that we're going to see in my next slide. Some futuristic scenario. You can think about smart cities, smart living cities. So these materials that combine structural properties of traditional building with attributes of living systems. In terms of public funding, this was actually explored by DARPA some years ago, the ELM program, and to explore design tools and methods for creating programmable, self-healing, living building materials. This, of course, has also potential to revolutionize military applications as well as civil society applications with remote, austere, high-risk, and post-disaster environments by developing living biomaterials that combine the structural properties of traditional buildings, again, with attributes from living systems. My next slide, you can see that some of the organizations that we can highlight in this particular topic is the WIS Institute in Harvard University, MIT, and Ohio State University. This is using our software. This is linknovate.com. And we actually even compare the number of references that we got in Linknovate with the number of references from Google Scholar. Here you can see in the slide, it's a bit fragmented because of the PowerPoint, but we are happy to share this in the handouts or if someone has a question about it. Finally, we profiled at the top and right promising startup, which is Ecovative Design. Ecovative is a pioneer in the design and manufacturing of mycelium-based biomaterials, and they have been awarded a DARPA grant a couple of years ago. The company has so far raised over $30 million US, and they have been working on leading research in synthetic biology, biochemistry with Columbia University, NYU, and MIT. The second
Manuel, sorry to interrupt. If you could hurry up a bit, because I would like to also have time for questions and, of course, the poll. Thank you.
Of course. In the second ranking, you can see some of the grants, some of the public funding in this particular topic. The same type of structure you can see for computing. So this is a topic that we have gone through in pre-FET, and you can see some of the phases of research that in this case, they are European, like Dr. Lee Cronin from the University of Glasgow. And we highlight there a futuristic scenario where a radical new machine, a computer, could enable advanced chemical processes to grow aircraft and some of their complex electronic systems. This has been done in collaboration with Biosystems Research. The Diala Molecule Network has been established in 2010 in the UK, and some of the leading research, as I said, is led by University of Glasgow. This is some of the ranking and public funding, which in this case is very scarce and led by the UK. And I'm gonna just touch upon one topic per each category from the topics that VRL commented early on. One from ICT, one from bio, and one from energy. From self-aware, and this is also directly extracted from linknovate.com, you can see a ranking of active organizations in terms of grants, and this is for the very niche topic of self-aware AI. So you can see Colorado School of Mines. Let me go a little bit below. Siemens, of course, Polytechnic University of Valencia, and some others. This is insights that you can see, that you can draw from the queries that I made in linknovate.com in less than 5 minutes. If we look at all the spectrum of data, not only grants, but taking into account any other signal, you can see that news dominate this space. So there's a lot of discussion going on in the media about self-aware AI, which is, of course, something that we know, but we see there some of the big tech discussing this particular topic, like IBM, Microsoft, Facebook, and Stanford University pops up as one of the, or the only one of the academic players at the top. So if we break down the type of sources that contribute to this particular signal in this topic, you can see that news dominated, and that is exponentially growing over the last 2 years. If we go to a bio topic like single cell resolution, you can see the difference in this kind of, with the same analysis. So if we run the ranking now, there's plenty of signal in all categories. So scientific publications, conference proceedings, grants, patents, and again, specialized news. And you see that academic players like University of Kyoto or Stanford University dominate the ranking of active organizations. Now, if we analyze the data sources, you can see that scientific publications and not news are the ones controlling or contributing more to the signals in this space. My last couple of slides for thermal energy. You can see again plenty of signal, and you can see a combination now of private organizations and academic ones. Abengoa is there, but also some universities and research centers. If we do, we can also draw a country breakdown, and I'm just going to leave you with a couple more graphs that we extracted from the Linknovate platform, like subtopics and their evolution over time. how keywords evolve over time, and you can see that solar somehow is declining. The keywords related to solar are somehow declining over the last 3-4 years. So there's more to thermal energy storage and conversion than solar. And the public funding. Public funding has been dominated by Europe compared to UK or US in this space. And you can see the French CNRS, Fraunhofer, and the French CEA as some of the most active organizations in this space. In fact, if we look at the social graph of the French CEA, they are connected with a myriad of players in this space, and almost every or all the relevant nuclei, social nuclei for this particular topic. Here I compare it with the German DLR. So these are some of the insights for these topics. I hope you enjoyed. Thank you very much.
Thank you very much, Manuel. Indeed, very interesting insights. I hope everybody has been able to see this detail. Now, I would like to ask my colleague to prepare the poll, and we have a limitation, so we cannot put you all the 9 topics, but we split it into 5 and 5, including other. So I would like you to, I mean, there's no restriction on the platform, but I would like you to limit your choice to 4 topics so that we put a bit of attention. So you really need to say, okay, I like more, but these are, and it may be that they are in the first part or in the second part, but please keep this in mind. So first we'll see a poll on the first 5 topics. Walter, if you could launch this already, and I will take, I will look, and I will take some question in this time. Okay. So Walter, can you launch the first poll, please? Okay. So I will have to submit also my questions. So to answer the poll myself, so I can see the screen. So the 2 ones will come one after another. So let me start with the question. Engineered living materials are relevant for medical application, regenerative medicine. So I see here some support for engineering materials. Mr. Servas Duterlo makes the case for synthetic cell. Indeed, this is a topic that we also received a suggestion from the member state. My understanding is that the synthetic cells basically has 2 branches, if you want. One is into the life sciences, and one more into the materials, for example, circular economy. This is indeed one thing we are looking into. I think the life sciences part it's quite well covered. So we will try. I mean, the idea is to select around 4 or 5 topics and to distribute them as more or less equal. So we cannot have, for example, 3 topics in health. But definitely, I fully agree, very, very promising. And then synthetic cell again. So more info about engineering living materials. I hope Manuel answered your question, Mr. Joao Moutinho. Otherwise, please send us or leave us your email, and we'll try to get back to you there. But this is definitely a very emerging field. So I've seen there was also another question about what are the applications. Okay, so that's still very low TRL, but the idea would be that this will replace some of the existing materials, or on a large scale or on the small scale. Another question is, did you compare the old foresight analysis with the real world, and how these have been implemented? I think this is a very interesting question. I will ask my colleagues, and perhaps we can even do a study. But it's true, is a bit of a hit or miss. And I would like perhaps to reserve this question to Radu here. Radu, did you had this comparison, like what were some old forest sites, and if they really materialize or not? Your mic is mute. If yes, now it's okay.
Okay. Thank you. So I'll try to check if I understood correctly. The question is the connection between foresight and what's happened next.
It really happened, the foresight.
What happened to the foresight? I think that some are connected, some are not. But I want to stress the difference between forecasting and maybe visioning. Sometimes a strong component of foresight is self-fulfilling prophecy. And I think that we are here to at least indulge a little bit into this. Because if we think that it's only prediction, so we are good at predicting, then it is no need for us to get involved into the game. It will happen. We just wait for it to happen. What we are looking here is to see the current trend. So we have a kind of baseline scenario. What is the world's going to? And then add a little of will, a little of resources, and change a little bit the future into the desired shape. Otherwise, foresight is not a panacea. Clearly, in predicting technologies, we have both good and bad experience, but I think that we always need to make assumptions about the future. So the value of foresight, I see personally, is not so much in predicting quite complex systems dynamics, is to enable us to make explicit our assumptions about the future to the best of our knowledge. Sometimes our knowledge is good enough, sometimes it is not.
Thank you, Radu. And let me mention here also that the Commission, under the coordination of Vice President Šefčovič, released the first, let's say, foresight report. So I encourage you to search for it. It's quite an interesting reading. The next question, perhaps also for Radu, because he referred extensively, does the topic of self-developing an aware artificial system also applies to topics like health? Or is it industrial application only? What do you think, Radu?
I think this is by nature very transversal. Of course, in health, the quite obvious application is in assisted living. So elderly people interacting with a robot, taking care of helping them managing their health at home. Then you need the robot to it is also a famous movie about that already. So the scenario was explored to its limits somehow. So I think that self-aware systems are critical in many fields. We don't yet think about all its application. Also, we have to bear in mind its final limits and its implication for our society. But I think if we achieve this, we would definitely live in quite a different world in our relation to the environment and what we understand to be the environment in health or in another domain.
Thank you, Radu. In the interest of time, so Manuel, there is a question for you. If you can unmute your mic. Your methodology seemed to focus on ongoing or past activity signals. How do you identify niches and prioritize upcoming topics? Quite a challenging question. Over to you.
Of course. I would say that every methodology that is based in data and in data mining and in signals is looking at the past to predict the future. And this is why no one has a crystal ball. But still, looking at the right type of signal you can draw better models or better predictions of what is going to emerge in the future. So we are getting better and better, and actually software can help us with mining vast amount of data. So before, software is precisely designed to help us draw insights from amounts of data that we cannot even understand. So this is where things changed over the last few years. So now with machine learning algorithms, with text mining, with data mining, you can draw new and different unexpected conclusions. There's in fact research done by UC Berkeley published recently, and they were able to uncover new scientific knowledge with text mining, and it's completely based on machine learning algorithms. So yes, of course, you are looking at signals from the past because somebody has had to written it before for you to crunch it and to process it into data mining. But looking at the right type of signals, I would argue that you can draw interesting insights and conclusions for the future.
Thank you, Manuel. So just to mention here on the last question that cancer on chips or diabetes on chip, definitely we have had projects not including body on the chip. So this is I think is advancing and progressing very rapidly, and somehow it's going towards higher TRLs. Okay, so somehow we have had very, very interesting projects already on that part. So now let me go to announce, which I guess everybody wants to hear, the result of the poll. I don't know if we can have the results on screen, but what I see here from the two questions is, and then percentages obviously referring to the individual call. So for example, in the first 5 questions, the one that was the most, let's say, popular was emerging technology for cell and gene therapy, with basically 21%, followed by self-developing and aware artificial system, 18%, again, compared to the first 5. If I have to take let's say the second part of the poll, from the most popular there, with 38%. So basically this qualify as the number 1 overall is engineering living materials. So very interesting here, and personally I agree. I think it's a very fetish, what we like to call fetish topics, at a very early research where we can give it a push eventually. And then there are 2 topics which are on the same on the equal footing, 26%, namely breakthrough thermal energy recovery, storage and conversion, and disruptive technologies for sustainable toxic-free farming. Okay, and there is, very interesting, it's only 10% other. Okay, and that means something that we did not capture. So if you allow me to somehow try to unify and the two, it's clear out of the 9 that ELM, engineering living materials, is the number 1, followed by disruptive technology for sustainable toxic farming, breakthrough thermal energy, and cell and gene therapy. So I would say very, very interesting results, and I would like to thank you to all of you that contributed. If there are any other questions, please put them in the chat or the Q&A box. This we are in time to finish. We will finish on time, and this gives me the opportunity to thank once again our speakers, Manuel and Radu. Thank you very much. I personally enjoy very much your insights. I think this is excellent research, and if we can bring, if you want, a grain of sand to helping this, let's say, achieving one or two of the extraordinary vision, that would be a great, let's say, a great honor for the Pathfinder program, and I would say a great, let's say, continuation for the FET. So I think we are almost there. Thank you very much, and looking forward to talking with you again, hopefully in a more physical setting, if you allow me. Thank you. Bye. Bye, everybody.
Thank you.